All right, so we're going to go ahead and take a look at yesterday's assignment and see if I can't clarify a few of these things from you, okay? So here we're going to go ahead and start with problem number 1, right? So right here, we've got our first problem, right? And what I really want you to focus in on is the system. So this is the system of equations right here, okay? So we're going to go ahead here. And I want you to notice here, when you look at a system of equations, the first thing you have to do is make sure everything is set up correctly. All the x's need to be in the same column. All of the y's have to be in the same column. And all of the constant terms need to be in the same column. And they need to have the equal signs in between them. So you got to make sure you line up your variables and your constants over on the right. And what this is going to do is this is going to allow us to rewrite this system as a matrix equation. So our matrix equation is going to consist of 3 matrices, right? Our first matrix is going to be A, which is our coefficient matrix. So I'm going to go ahead and I'm going to make a 2 by 2 matrix because I have 2 variables. The first column will be my coefficients of x, and the second column will be my coefficients of y. If I look down here where I have my first column, I can see my coefficients of x are 1 and 2. My coefficients for y here are going to be 1 and 3. So that's how I get my coefficient matrix A. Now I'm going to multiply that times my variable matrix, which will be x, right? And that's just going to be my 2 variables, x and y. And if I multiply these, it's going to equal what's called the solution matrix, which is our constants, which is going to be S. Or in this case, the numbers on the other side of the matrix, which are 4 and 9. Okay, so that's the most important thing, is making sure you can figure out what matrix A, X, and S are. Okay, now if I were to actually multiply these out using my matrix multiplication, I know I'm going to go across and down here, right? And if I go across and down, I'll get 1 times X, right, plus 1 times Y. So I end up with X plus Y. Oh, doesn't that look familiar, right? And I can see here it equals 4, right? So there's my 4 right there. So you can see through matrix multiplication that this matrix equation I've set up actually represents the exact same system of equations we have originally in the problem, okay? So now what I'm going to do is I'm going to go ahead and take a look at just some algebra that we know, right? So we know here if we have, let's say, a basic equation like 3x equals 6, right? If I want to go ahead and solve this equation, I would go ahead and I would say, all right, how do I get rid of that 3? Now, you're used to dividing by 3, but instead what we're going to do is we're going to multiply by the inverse. Now, the multiplicative inverse of 3 is 1/3, because if I do 1/3 times 3, I get 1, which is the multiplicative identity. And 1 times anything is just itself. Now, we also know from algebra, whatever I do to one side, I have to do to the other. So over here, 1/3 of 6 is 2. So this is how we do algebra, and you guys know all this, right? Now we're going to take a look at our matrix equation, right? So our matrix equation here is A times X equals S. A, X equals S. Now I'm going to do the exact same thing, right? If I want to go ahead and solve this equation for X, I need to get rid of that A. Now we know these are matrices, so I'm going to multiply A times its inverse. Because I know a to the negative 1 times a gives me the identity matrix. And the identity matrix times any matrix gives me itself. Now likewise, whatever I do to one side, I have to do to the other side. See, it's the exact same thing you remember from algebra, okay? Now here, one important thing, I have to multiply from the left-hand side because we know that matrix multiplication is not commutative. This inverse for matrix A is going to be a 2 by 2. S is a 2 by 1. I can multiply a 2 by 2 times a 2 by 1, but I cannot multiply a 2 by 1 times a 2 by 2, right? It doesn't match up. So every time I do this, it's always going to be x equals a to the negative 1 times s. So in this case, I can see here, x is my matrix xy. A is my matrix 1, 1, 2, 3. And I'm going to have to find the inverse of that. And I need to multiply that times my matrix S, which is 4, 9. Now, I don't actually need you to do this calculation. We're going to go ahead and use a calculator to help us with that, okay? So I'm going to switch over to my calculator here. And the first thing you need to do is find the green button that is alpha. And this calculator is the exact same thing as a TI-84. So I'm going to hit here alpha, and then the top center button is zoom. So I hit alpha zoom. That brings up this menu. Now here I'm going to say I need 2 rows and 2 columns. I'm going to hit enter. And my matrix was 1, 1, and then I think 2, 3. But let me make sure. That's right, 1, 1, 2, 3. I'm going to go outside the matrix, and if you look 2 buttons down from the alpha button, right underneath math is a button that says x to the negative 1. That's my inverse button. I'm going to hit that button. Now I'm going to hit alpha, zoom, and this time I need a 2 by 1 matrix. So here I'm going to go ahead and set up for a 2 by 1, and I'll type in my 2 numbers, which were 4 and 9. So 4 and 9. And I hit enter, and it shows me my matrix over on the right, which is 3, 1. So over here, I can see this matrix here, right, was xy is equal to 3, 1. So I have solved my system equation for both variables. Now, if you remember back to Algebra 1 and Algebra 2, we're actually talking about where those 2 lines intersect, where those 2 equations have a point in common. So I report my answer as an ordered pair, which will be 3, 1. Okay, so hopefully you find this to be a little bit more accessible than what you did yesterday. I'm going to show you the exact level of work that I need to see on each problem with number 2, because this is overkill, right? So here, first thing I want you to do is make sure everything lines up. My x's, my y's, and my constants with my equal signs here in the middle. I know every single time the equation is going to solve the same way. X equals a to the negative 1 times s. So I know my variable matrix x is xy. My coefficient matrix will be 3, 1, 1, negative 6, 2 the negative 1 times my constant matrix 0, 38. This is what I need to see. I need to see you set up that equation, right? I actually don't even need this part. I just need this, okay? And then here, you can go directly to the calculator, do the rest of the work. So again, that's alpha, zoom, 2 by 2. And I believe that matrix was 3, 1, 1, negative 6. Let's make sure. That's right, 3, 1, 1, negative 6. To the negative 1, don't forget that. That's the most common mistake students make. And then alpha zoom, 2 by 1 matrix, and it was 0, 38. I hit enter, and I report my answer as an ordered pair, 2, negative 6. So my answer will be 2, negative 6. So that is the level of work I need to see on each problem. Now we are going to do 3 variables. Same thing, you'll make sure your x's are lined up, your y's are lined up, and your z's are lined up. You'll make sure your constants are on the other side of the equal sign. If there's ever a variable missing from an equation, you can put a 0 in. So if there's like no z, you can put 0z and it'll still work out. And that's how we set these up. I'm going to go ahead and write out the equation and the solution I expect to see for these problems and upload them to Canvas so you can check to make sure you set up your matrix equation correctly or you found your solution correctly. And then you can go ahead and try the 3 by 3s for today. Hopefully that clarified for you. All right.